This will be for the con exercise. Interpret change in exponential models with manipulation. All right, for most of these, the write-up is not that important. You really want to focus on the equation and what they're asking. I'll just read it anyway. Ocean sunfishes are well known for rapidly gaining a lot of weight on a diet based on jellyfish. The relationship between the time t and days since the fish is born and its mass m of t in milligrams is modeled by this function. Complete the sentence, round to 2 decimals. The sunfish gains 2/7 of its mass every blank days. Okay, in order for the sunfish to gain 2/7 of its mass, you need to multiply by 1 plus 2/7. Okay, the 1 represents 100%, and then you're adding 2/7 of that. So 1 is actually 7 over 7 plus 2 over 7. That's going to be 9 over 7. Okay, so you're going to have to multiply by 9 over 7 in order to gain 2/7 of its mass. All right, so it said in the write-up, t is the number of days. So we want to create an equivalency here. The number 4 is being multiplied by this factor right here. We don't have to worry about whatever the initial value is. Okay, but this 81 over 49 is to the power of t. I'm going to equate that to 9 over 7. And that is going to be to a certain power itself. And we want to figure out what that is. Well, if you look at 9/7 and 81 over 49, we know that 9 squared is 81, and we know that 7 squared is 49. Okay, so if you take 9 over 7 and square it, you're going to get 81 over 49. Okay, so in place of 81 over 49, I am going to make this 9 over 7 squared. Okay, so 81 over 49 is equivalent to 9 over 7 squared, and I'm going to raise that to the power of t. All right, now when you have something with an exponent raised to another exponent, you just multiply the exponents. So that's going to be 9 over 7 to the power of 2t. Now remember, t is in days. Okay, so every time t increases by 1 day, this exponent is going to be 2 times that number. Okay, so we basically have 2t equal to 1. And then if you divide both sides by 2, t is just 1/2. Okay, so it basically increases. It basically gets multiplied by 9/7 every half day. All right, and if you think about it, if you take 1/2 and plug it in place of t, it's going to be 2 times a half. The exponent is just 1. So every time the day increases by a half, it gets multiplied by 9/7 and it gains 2/7 of its mass. So in the box, it's just 1/2. Okay, I made a mistake on this one at first, but I came up with a better way of explaining it. Once again, this function here represents the mass of the ocean sunfish. T is the time in days. All right, so we're looking at this here, and they want to know each day there is a blank percent in either addition to or removal from the mass of the sunfish. Okay, and you round to the nearest percent. So all we have to do is see what it's being multiplied by each time or each day. So let's start at t equals 0. Okay, so we're going to have 1.35 to the power of 0 over 6 plus 5. Okay, that whole thing is the exponent, 0 over 6 plus 5. So that's going to equal 1.35. 0 over 6 is just 0, plus 5 is 5. All right, so it's going to be 1.35 to the 5th. And then at t equals 1, okay, I just incremented the day by 1 unit. It's going to be 1.35 to the power of 1 over 6 plus 5. Okay, so 5 is the same as 30 over 6. Okay, so this is going to be 1.35, and 1 over 6 plus 30 over 6 is going to be 31 over 6. All right, so it's multiplied by this on day 0 and by this on day 1. So in order to see what it's multiplied by, I'm just going to take this and divide it by this. All right, so 1.35 to the power of 31 over 6 divided by 1.35 to the 5th. But instead of 5th, I'm going to use 30 over 6. And in this case here, since the 1.35s match, we keep that and we can just subtract the exponents going down. 31 over 6 minus 30 over 6 is 1 over 6. This is what it's being multiplied by each time t increases by 1. So I want to do 1.35 to the power of 1/6 on the calculator. Okay, 1.35 to the power of, parentheses, 1 divided by 6. And hit equals. And basically, you want to round to 2 decimals at first because it said round to the nearest percent. Basically, this is going to equal 1.05. Okay, you look at the third decimal. If it's less than 5, you round it down. So 1.05. So if something is multiplied by 1.05 and we subtract 100%, that's going to be 0.05, which equals 5%. So it's going to increase. It's going to be in addition to 5%, and that's each day. Okay, remember we said if you multiply by 1.05, that increases something by 5%. All right, I'll just skim the write-up. T is in days. N is the number of locusts. All right, and they say round your answer to 2 decimal places. Every day the locust population is multiplied by a factor of what? All right, this one's pretty easy. It said T was the number of days, and they want to know what happens every day. So we can ignore the initial value. We just want to see what it's being multiplied by each time. All right, so if I plug in 1 in place of T, that's going to be 0.49, 0.49 to the power of 1/2. Actually, I'll show you like I did last time. All right, at t equals 0, before the days start to count, you're going to have 0.49 to the power of 0 over 2. Okay, that's 0.49 to the 0, which just equals 1. Okay, then the next day at t equals 1, it's going to be 0.49 to the power of 1 over 2. Remember, 1/2 is the same as taking the square root. I know the square root of 0.49 is just 0.7. You could do that on the calculator if you like, but 0.49 to the 1/2 is 0.7. So I take this and divide by the previous value. 0.7 divided by 1, that's just 0.7, which is the same as 0.70. That is a loss of 0.30, which is 30%. Well, we don't need percentage this time. Okay? In fact, we don't even need to know what the loss is. They just asked us what the multiple is. So it's going to be multiplied by 0.70.